Okay, so today's notes are on systems of inequalities. So our content objective is going to be to solve systems of linear inequalities, and the language objective will be to use the correct terminology when describing that process. So the first key point I want to make here is that this whole process is just combining the skills of solving systems of equations with graphing inequalities. This is just combining two skills you all already have to further them. So we're taking two skills we already have and applying them to something very similar but slightly more in depth. So our example asks, what is the solution of the system of inequalities for 2x minus y is greater than or equal to -3 and y is greater than or equal to -1/2 x plus 1. So that's our system of inequalities, and we need to find the solution. So what we're going to do first to do that, step one, is to rewrite. So both equations, rewrite the equations. So both are in slope-intercept form. So we're rewriting so they're both in slope-intercept form. This one already is, so I'm going to take 2x minus y is greater than or equal to -3. I subtract 2x from each side and I get negative y is greater than or equal to -2x minus 3. I have to get rid of that negative, so my last step is to divide everything by -1. So then I have y, since I divided by a negative, I have to switch the direction of my inequality. So y is less than or equal to positive 2x plus 3. So that is my rewritten equation in slope-intercept form, and then I still have my other equation, -1/2 x plus 1. So these are my two linear equations, and my next step, step 2, is going to be to sketch each inequality. I need to pay attention to things like solid versus dashed lines, since we're doing inequalities, and the direction I'm shading, so shade above or below. So I need to make sure I'm not only sketching my graphs accurately, but also paying attention to those details that are specific to solving or to graphing inequalities. So I'm going to start by graphing this. So I have my x-axis, my y-axis. I'm going to make this a somewhat spread out graph. So I'm going to go by 4s, or by 1, sorry, up to 4, down to 4, and then I'll make these somewhat spread out as well. So I have my x and y axes. I'm going by units of 1. If I sketch this one first, I start at +3, and then I have a slope of 2, so I'd go up 2 over 1, but since that's hard to fit on here, I'll go the other way, so I go down 1, 2 over 1. So this graph, again, it's going to be solid since it's greater than or equal to, and it's going to go something like that. So there's my first line. Since it's less than, I'm shading below, so I'd shade, if you can't quite see that, I'm shading down like that, and that would continue as that graph went up. My next equation is y is greater than or equal to -1/2 x plus 1, so I'm starting at +1, and this time it's a negative slope. So I go down 1 over 2, down 1 over 2, and then this way up 1 over 2, up 1 over 2. So then this line goes something like this. Again, it's solid since it has the equals to part of the inequality. And this time I'm shading so that it is greater than. So I would be shading above this line. So I would shade up. If you look now, you can see that this section here is where the two shading sections overlap. So the third part of this is the solution is the double shaded section or where shading overlaps. So at this point, I know that this section is my solution set. So I'm going to shade that a little bit darker so it's clear. The double shaded section is at this point my solution because it should satisfy both inequalities if I have shaded them correctly. But just to verify, for step 4, I want us to check a point from the shaded region, double shaded region. So I'm going to check a point from the shaded area in both equations. So there's a few different points. You could choose any point that's in this double shaded section. I'm going to choose one of the easiest ones that's on the axis. So I'll choose 0, 2 as my point. So my checkpoint or test point will be 0, 2. So I'm plugging in 0, 2 to my first equation. So I will have 2 for y is less than or equal to 2 times 0 plus 3. So 2 is less than or equal to 3, which is true. So that works for that equation. And then if I plug it into the other one, again, I get 2. This time is greater than or equal to negative 1/2 times 0 plus 1, which comes out to 2 is greater than or equal to 1, which is again true. So my shaded section is correct, and I have now determined the solution, that double shaded section. All right, let's do a quick check on this. Make sure you jot down any questions you have on this section. I'm going to turn the page. Okay, so our quick check is again, what is the solution of the system? X plus 2y is less than or equal to 4, and y is greater than or equal to negative x minus 1. So try that one on your own. Pause it, give yourself a second. I'm going to go over it. So the first thing I'm going to do is rewrite this equation. So I have x plus 2y is less than or equal to 4. I subtract x from both sides, and I get 2y is less than or equal to negative x plus 4, and y is less than or equal to negative 1/2 x plus 2. So negative 1/2 x plus 2 is my new equation, along with my original equation of y is greater than or equal to negative x minus 1. So I'm going to graph this now. Since they both have negative slopes, I know that it's going to be kind of farther out to the left when they intersect. I'm going to sketch this with slightly more space on the left side. I have my x and y axes. I'm again going to go by ones. I have 1, 2, 3, 4, 5. 1, 2. Oh, that's 1, 2, 3, 4, 5, 6. Ignore that one. 1, 2, 3. Okay. I'm going to go a little farther out here. Go to 7. So this is negative 7 over here. And then I have 1 there. All right, so now I'm going to start plotting. I'm going to start with this one. So that starts at 2. And I'm going down 1 over 2, down 1 over 2. And then this way, 1 over 2, up 1 over 2. So this line is going to look, again, it's solid since it's equals to, and it's going to look something like this. And since it's less than, I'm shading below. So I'm going to do that lightly since I know I'm looking for the overlap section, but I know generally it's shading downwards. This one is negative x minus 1, so I have my negative 1, and it's going up 1 over 1, up 1 over 1. So this line now has a slope something like that. So, and this time I'm shading so that it is greater than, so I'm shading above this line. So again, I'll do it lightly. but I see that this section, this triangle that I've made here, is really where it should be shaded since that's where they overlap. Last thing I need to do is plug in a test point. So this time, my convenient point of 0, 0 is in my graph. So if I plug in 0 is less than or equal to -1/2 times 0 plus 2, I get 0 is less than or equal to 2, which is true. So that one works. And then if I plug it into the other one, I get 0 is less than or equal to -0 is just 0 minus 1. So 0 is greater than or equal to -1, which is again true. So I have properly shaded that section. All right, make sure you write down any questions, comments, concerns you have on that. I'm going to give you one more challenge problem that kind of combines a couple things we've learned but not talked about explicitly. So I want you to determine what is the solution of the system. Y is less than or equal to 3 and y is greater than or equal to the absolute value of x minus 1. So the absolute value function and a horizontal line, try that one out. I'm going to go over it now. So again, I'm going to draw a graph to start. So it will look something like this. 1, 2, 3, 4, 5. This is my y-axis. Okay, so I have a graph that looks like this, x-axis. I'm going to start with my y is less than 3, so that's just a horizontal line. It's less than or equal to, so I can draw it as a solid line right here. I know it will shade below, so I'm doing that very faintly, but I know it's shading below that line. Now I have my absolute value function. I know that the subtracting one is inside the function, so I'm moving the vertex over to the point 1, 0. There's no stretch or vertical translation, so I'm just going to draw my typical slope of up 1 over 1 on both directions. So then I have an again, it's a solid line because it is equal, it has the equals to component. So I graph it like this, and this time since it's greater than, I'm shading up. So again, I'm doing that lightly, but you should notice that the overlapping section is going to be this triangle in here. So that will be my solution to my graph. I can plug in a test point just to make sure. So this again would be the point 0, 2. So I can try the test point 0, 2. If I plug that in, there's no x value, but 2 is indeed less than 3, so that is true for my first equation. If I plug it into my second one, I plug in 2 for y is greater than or equal to 0 minus 1. 0 minus 1 would be -1, which the absolute value of -1 is just 1, so 2 is greater than or equal to 1. That is again true. So both of those prove true. I've solved it correctly. All right, make sure you write down any questions, comments, concerns you have on this so we can go over it together in class.